Hello guys, welcome to my YouTube channel. In this video, we will start discussing on linear regression. What do we mean by linear regression? Okay. So before going into linear regression, we need to brush up our understanding on equation of straight line. Okay. So we have already seen the equation of straight line, right, in our high school or higher primaries, right? So the equation of straight line is y is equal to mx plus c, right? So m here stands for slope of a line. Okay, right? Slope of line. C is y-intercept, correct? Y-intercept, and in any straight line equation, it will be constant, right? It will be some constant, right? And how does the straight line looks like? So if I just draw x and y coordinates here, and let's say it is passing through the origin. So this is my straight line, and its equation is y is equal to mx plus c. It has some slope, right? It has some slope, and it is 0 in this case because it is passing through the origin. That's why y-intercept, which is term c, it will be 0. So this is the simple equation of a straight line, right? So what happens if m is 0 and c is 0? Okay, so this straight line, so we have the straight line here, right? So this straight line will just fall on this x-axis, right? So the straight line will be falling on this x-axis since there is no slope associated with it, and also y-intercept is 0, right? Now what happens if m is some value, right? Some value, and c is equal to 1, right? So it's not 10. Let's say c is equal to 1. In this case, we will have the straight line, but this is x, this is y. Let's say these are the values 1, 2, 3, 4, and likewise we have on the x-axis as well. Okay, 1, 2, 3, 4. Okay, in this case c is equal to 1, right? But m is not 0. So there will be a slope associated with the line, but the y-intercept will be 1. Instead of passing through the origin 0 here, straight line will be passing through 1 here. Okay, so this is again the equation of the straight line. The equation remains same, just c will be 1 and m has some value associated with it. Okay, now what happens if m is 0 and c is equal to 1? So in this case, the straight line will be parallel to x-axis, but it will be cutting the y-axis at 1, right? Because c is 1. Okay, so this is how the equation works. So this is again y is equal to mx plus c. So based on the value of c, the straight line will cut through the y-axis. Okay, based on the value of m, the orientation of the line along the x-axis changes. Okay, so this is the basics of our straight line equation, correct? Now with respect to machine learning, what we have is we have some values associated with x and y. Okay, we have for some values of x, we have some associated value of y. What we have to do in case of linear regression? We have to find m and c, right? So sorry, this is supposed to be m and c we have to find. Okay, so in order to represent it in a more general way, with respect to machine learning, linear regression hypothesis is given as h theta of x is equal to theta 0 x0 plus theta 1 x1. Okay, so this is the equation of linear regression. To be more specific, it is called as univariate linear regression. Okay, this is called as univariate linear regression. Why it is called univariate? Because we have only one variable x1. Okay, x1 here, right? This x0 for mathematical to make mathematics more easy in order to solve the equation, we treat x0 as 1 always. Okay, always x0 will be 1, and theta 0 and theta 1 are called as learnable parameters. Okay, so these parameters we have to learn. How we are learning? Based on the values that we have for x and y. Okay, so in this equation, if you can relate this hypothesis to equation of straight line plus theta 1 x1, and the equation of straight line is y equal to mx plus c, right? So here c is constant, right? It is the y intercept. You can treat this term associated with this, okay, and theta 1 x1 to be associated with m and x, right? For some value of x, you can treat it as x1, and m you can treat it as theta 1. Okay, so in this hypothesis, theta 1 and theta 0 are our learnable parameters. Correct? I told this already before, right? Learnable params. And you can associate these two with respect to the equation of straight line variables. Theta 1 will be m, slope of the line. Theta 0 you can associate with c. Okay, so c. So this is how a basic hypothesis of linear regression is formulated. So let me write it clearly once again. So all we have to do is, let's call it as a hypothesis for univariate linear regression. So what it is? H theta of x is equal to theta 0 x0 plus theta 1 x1. Okay. So this is a hypothesis, right? I will talk about the notation in my next videos, but just remember this univariate linear regression hypothesis. And in my next videos, I will talk how we can find out the optimum values for thetas. Okay, thetas constitutes of theta 0 and theta 1. Okay, so that's it for this video. If you guys have any questions on the equation of straight line or the basics of this linear regression hypothesis, please post it in comment section. I will try to answer them. See you next time in my next video. Thank you. Bye bye.